Now it's getting
What happens now is that we're going to start messing around with the different possible degrees.
And you didn't even give me my homework.
What happens now is we're going to change the degrees of both the numerators and the denominators. And we're going to have different degrees on top and bottom. Sometimes they're going to be the same and things like that. And there's going to be a bunch of little rules that we have to follow. But each and every one of these problems kind of falls into the same idea. If you do the same steps each time, actually winds up being pretty simple. What we're going to focus on mainly today is setting up, plotting our asymptotes, figuring out where everything is going to go, and if we have a little bit of time, we'll wrap a few of them here and there. But what I want to do is start by not having you write everything out because it's a bit of a pain. I have this little cheat sheet that I just photocopied from the book, and you guys usually just throw it in your notes because it's easier. And what I do is just kind of explain what all this means. Yes, sir. What we're looking at here, while you guys are passing those out, just a refresher. Domain and range, when we're dealing with these things, I know a lot of times you guys tend to forget this stuff. Your domains are all possible x values. Your range are your all possible y values. Your domains and ranges are restricted dependent upon the asymptotes. Your domain is restricted by vertical asymptotes. Okay? Domains are restricted by vertical asymptotes. When you have a vertical asymptote, that means x can't equal that value. That's why we call it a domain restriction. Same thing on a range. A range restriction occurs at horizontal asymptotes. When you have a horizontal asymptote, that just means you can't go past it. You can't go through it. So it's restricted by the horizontal asymptotes. That's how you get domains and ranges out of these things, by the restrictions within. That's exciting. Is nobody here this time? Actually, Seth thought of a really good one. We'll do it for next year. We put the action in fraction.
Sounds like
So anyway, let's go through what all this stuff means on this sheet. This sheet looks like a whole bunch of hieroglyphics. There's a lot of weirdness going on. What I want to do is explain that all this is a polynomial in descending order. Divided by another polynomial in descending order. That's all it is. It's two polynomials written in descending order being divided. We say that they are of higher degree, whereas yesterday we dealt with polynomials with degrees of 1. We had a constant divided by a degree of 1, and then we had a polynomial with two of them with degrees of 1. And when they had the same degree, we wound up with this nice little play on where the asymptotes occurred. Works the same way today. And I think I alluded to some of that yesterday, where if we had squares in both top and bottom, we'd wind up with horizontal asymptotes at their leading coefficients. It holds true through all polynomials.
Is it the same variable?
They will. It's going to be x is y. These are all functions. F of x equals something x squared.
So
X.
x1 will
No, because you can't simplify over addition. What'll happen, and I think I know where you're going with this. What can happen, and don't write this out here, is if you wind up with, let's say, x minus 4 quantity squared up top, and you had x squared minus 16 in the denominator. If you have something like this, and we do a little bit more of this in pre-calc than we do in Algebra 2, is that you still can get the zeros of the denominator. The zeros of the denominator are still where it equals 0. It would be at plus or minus 4. Everybody okay on that? Yeah. But what happens here is when you factor this out, that's basically what that means, right? You simplify because these are all terms. So in theory, what happens is you only have one asymptote at the non-simplified out. And what would happen in the curve itself is that when you would curve, as you go through wherever it is at 1, 2, 3, and 4, there'd be an open circle within the curve. There'd just be a hole. It would be another asymptote, it would just be a hole, because it's a simplified factor that comes out. We don't deal a lot with that in Algebra 2. You'll see it next year in pre-calc. And it's that simple. That's really all there is to it. Why? It's just not in your book. So what we have again are polynomials of bless you. Call it polynomials of higher degree. Just bless you. Anything that starts with a higher degree than 1, really. Your x-intercepts are always going to be the zeros of the numerator. So we have x-intercepts at the zeros of the numerator. We have vertical asymptotes at the zeros of the denominator. Yeah, this is kind of what the sheet's talking about here. That's the first two things. When we work with these things, we're talking about in terms of real zeros also, just so you remember. We're not worrying about imaginary zeros. No, you won't have to provide. The last part is where things get confuzzling. What happens with this last part, they're talking about the different degrees. The degree of the top versus the degree of the bottom. The degree of the top is what they're looking at is the m value. So if the degree, of the top is smaller than the degree of the bottom, m is smaller than n, then you have a horizontal asymptote at y equals 0. So you have three different things to check for horizontal asymptotes. If the top degree is smaller than the bottom degree, it's at y equals 0. If it's not that, then they could be equal. If the top degree equals the bottom degree, it's the same thing as it was yesterday. It's the leading term coefficients as a fraction. I'm going to write it as y equals a over c. So it's the exact same thing as what we did yesterday. These two guys had the same degree. M and n were the same. Both had a degree of 1. So we looked at the leading term coefficients.
Do you rewrite that?
What's that?
Is that just the same equation over there with the bottom and top?
Oh, there were degree of top, degree of bottom, there were top degree, bottom degree?
Yes, they're the same, right?
It's the same thing, yeah.
Okay.
I didn't realize I flipped it. Now,
Gosh, my God.
here, I'll rewrite it. Which one do you think is easier? Bottom? You want it as degree top, degree bottom, or
Bottom degree.
you want them like this?
Yeah.
All right, I'll rewrite it here. Sorry, I had no idea I did that. I wonder if I did that third hour. All right, so if the top degree, oh, that makes sense. The degree is the degree.
That's good. That's clever.
Could have thought that one through a little bit better.
We can give you an A.
Wait, just to repeat.
Yo.
At
And looks like we're exactly what's exactly right.
I'm rewriting it out. It's gonna be the horizontals will be at y equals that a over c.
Oh, okay.
Think of it as the leading term coefficients. Yeah, it's the same thing as it was yesterday. It's the same thing when you had the same degree. So it's just leading term coefficients. So these are your lead coefficients. And then the last one, if the top degree is greater than the bottom degree, bless you, we have no horizontal asymptote. Okay? We will have a slant asymptote sometimes, but we'll get there. What day are you? Okay. It's not like they're trying to approach you or anything. Approach the asymptote. The asymptote's not approaching you, you're approaching.
Some sort of way approaching person.
Let's just start with the easier. That was mean, Kate, and I apologize for that.
Mom jokes.
Anyway, so let's look at this one. What I want to do here with this, the first couple examples, is just walk you guys through how you're able to find all the critical information from the given function, all right, from the given expressions. So we have y equals x squared plus 4x minus 5 all over x minus 6. And I'm just going to start with step 1, find your x-intercepts. Your x-intercepts are always going to be the zeros of the numerator. So in the numerator, I just need to factor. So what times what is negative 5? You add together to get positive 4.
No, 5 and then
5.
Bless you.
Thank you.
So if I factor out, I get x plus 5, x minus 1. So I'm going to have x-intercepts at negative 5 and 1. You okay with that? Now I go to the next thing. My vertical asymptote can be at the 0 of the denominator. So my vertical asymptote is going to be at x equals 6. Yes, sir?
So what if the denominator is the vertical asymptote to x? Can you just say none?
Because it has to be real.
So what do you say?
No. Yeah. So this here would give me vertical intercept, or vertical, x-intercepts of negative 5 and 1. And then I have a vertical asymptote at 6. Now, obviously, we don't know enough about these graphs yet to figure out how are we going to plot them, how are we going to find other values and stuff like that. But since there's an asymptote on towards the right there, that means there's probably more graph to the right of it. Since I have 2 points already on the left, so I might have to start guessing where the other ones would be. So let's just try this. Another really easy point that we can always find is your y-intercept. What's your y-intercept always going to be located when x is equal to what? 0. It's not a bad idea to always try to find your y-intercept because it might help you within finding what these curves are doing. What's that? Oh, that's what you was talking about. Sorry, I counted 6 after. Sorry, she realized I put the vertical asymptote at 7 because I counted 6 after the 1 by mistake. So where's your y-intercept on this? 5, 6. If you put in if you substitute in 0, you're going to get 0 plus 0 minus 5, 0 minus 6. You get negative 5 with negative 6. You get 5, 6. Okay. Now, obviously, we have not gotten to the point of graphing these yet. So I just want to show you that you can still get an idea by using the calculator. I have it open. I don't.
There's no horizontal axis.
Oh, yeah, we didn't get to that part yet. The horizontal asymptote, I skipped on that one. There is no horizontal asymptote here because the top degree is larger than the bottom degree. So there's no horizontal. Yes, ma'am?
Who takes the pictures of your children? Like, they're just really good pictures.
Oh.
How do you not
You
know?
don't know who takes pictures? What?
How do you know I didn't take
Look,
it?
it's such a good picture.
I know it's a good picture.
I'm just asking.
Miss Jenny did.
What's so funny? Why did you look at me? I didn't even.
On yours, it only has algebra.
Oh, I still have I still use the same thing with pre-calcs. I still put the pre-calcs up in it. So if I go into here to my y equals, I can still put that in. You guys know how to put a fraction in?
Yes.
Oh, yeah.
Was it, I forgot it.
Plus 4x.
Always talking.
For something that wasn't here yesterday, you might want to stop talking as much. And jumping around.
I'm not talking just then.
Come on. Obviously, at this point, you're just seeing one part of it. One of the things you can do, since you know that within the problem that there's a vertical asymptote at 6, is adjust your window to see more of the stuff on the right-hand side. Adjust your window. Maybe go to the x maximum, change it up to maybe 30. And then, obviously, since our curve was doing something real quick here, it might be doing that further away. Change your y maximum too. Sometimes it helps just to see above. You get an idea.
Yes.
I think I had enough value, didn't I? Oh, it's going to be bigger than that one then. Where would I had to have it at? There we go. So you can sit there and mess around with it, and you'll start to notice that we have that vertical asymptote there. There's a slant. There is a slant. There is a slant asymptote that does occur between these two. And we'll talk about that. We'll get to it. We'll get to it. We'll worry about that when we start graphing more. Yes, ma'am?
So, how did you find the value on the y-intercept?
The y.
How did you find that point?
This one here?
Yeah.
It's always x equals 0. I just substitute in 0 for x. To get the y-intercept, you just put 0 in for x. Now, this first one here, I'm just giving you guys an idea of what it's going to look like. Some of the ones that you're going to graph on your own, they're not going to be this difficult. We're going to have to start fishing around and look to guess numbers to put things in. Okay? Yes, ma'am?
If it's 5, 6, then how would you find this?
It's not. The first tick mark is at 1. It's right below 1.
Oh, 5, 6. Okay.
It looked like there was one there because of when I was circling, I might have just left it off to the side. So let's look at another one. Set up another one.
Wait.
No, guys, I wanted to start to get you the habit of doing this so far. When I give you things that you're going to graph, it's going to be a little bit easier. There'll be stuff that'll fit cleaner to work with. Okay? All I want to do is identify parts. Work through this, okay? Identifying parts. Why I said that in the beginning.
You don't pay attention.
Obviously. Same deal. Y equals 3x squared minus 13x plus 10 all over x squared plus 8. As you start to walk through something like that, you go through the same process of your list. First thing you want to do is find the zeros in the numerator. Those give you the x-intercepts, which means you have to factor Oh boy, leading term coefficient not equal to 1, which means we want to group. What times what is 30? You add together to get negative 13.
Negative 10, negative 3.
So 3x squared minus 3x minus 10x. And you group it. So you have terms of 3x minus 10 and x minus 1. That gives you x-intercepts of 10 thirds and 1. Then you go to your vertical asymptotes. Vertical asymptotes occur at the zeros of the denominator. Do I have any real zeros in the denominator? Nope. There are none. Horizontal asymptotes, on the other hand, my degrees are the same. My degrees are the same. I've got the top, the numerator degree is 2, the bottom, the denominator degree is also 2. So this is when you worry about looking at the coefficients, just like we did yesterday. So your horizontal asymptote's at 3. And then obviously, we would just go ahead and substitute the values and go for it. But for here, we're just looking at value. Okay? Obviously, they had the same, just like yesterday, how they had the same degrees. It's just leading term coefficients divided as a fraction. That's all. All right.
Why is there no vertical?
Do you have a real zero? Wow. All right, let's try and plot one then.
Oh boy.
Let's plot it and go with the domain and range. So we have y equals, excuse me, 4 over x squared plus 1. X-intercept. Do we have any x-intercepts? Nope. Vertical asymptotes.
No.
No. Good.
Horizontal is equal to 0.
Horizontal is equal to 0. Good. So it's y equals 0.
Because the degree on the top is less than the degree on the bottom.
Oh,
Okay, good. Degree on the top is less than the degree on the bottom, so your horizontal asymptotes can be at y equals 0. So now you have an idea of where to start. What's the very first point that I can find here? Y-intercept. My y-intercept in this case is what? 4. Everybody okay with that? The y-intercept's 4 because I just substituted in 0 for x. Oops. So I know my y-intercept's at 4. Now I just got to figure out what the curve is doing. Pick numbers on the left and the right of it. Negative 2, negative 1, 1, 2. What's negative 2 squared? What's 4 plus 1? 5. So if x is negative 2, it's 4/5. Hey, if x is positive 2, what would it be?
4/5.
4/5.
oh,
If x is negative 1, what's negative 1 squared? What's 1 plus 1? What's 4 divided by 2? 2. So at negative 1, it's 2, which means at positive 1, it just so happens to be there. It's nice when you have them positive difference. So is this curve ever going to touch the asymptote?
No.
No. So it's coming up and coming back down. What is your domain? Is there any domain restriction here? No. So your domain is all real. Now what about your range? Yes, sir. All real except 0, but am I ever going to be negative?
Oh, all positive.
Am I ever going to be bigger than 4?
What the?
Think about.
See what happens here. See how I'm bounded? I'm never going to be,
Like the X in the middle.
my y value is always going to be larger than 0. It's never going to equal 0. But my y value can equal 4. So there's a specific, I hate to say this word, range for my range.
Wow, Murph.
How about there's a specific parameter?
That's too big a word.
I'm not sure all the people in here understand that word.
Sorry, I'm just chemistry.
Okay? That's what this looks like. See how this was a lot easier to substitute values in than the first one I showed you? Remember, the first one I was showing you guys was just, what does it look like? What do you have to do? Well, this is what you do to set it up. Okay? As you get into the actual graph part, it's not as complicated as it looks. All right. Should we try one more? I was stalling, I was making sure. Wait.
That one.
That one. Yeah, let's do this one. I think it's this one. So we have y equals 3x squared over x squared minus 4. And we're going to find out all of our critical stuff and get an idea of how to sketch the graph. So always start with your x-intercept. What's your x-intercept going to be? 0. What's that?
There's like a flash.
It's called the reflection of the lights of the buses as they're driving into the parking lot.
Why is it 0?
Set the numerator equal to 0. It's all for x.
Oh, yeah. Why is it equal to 0?
Divide 0 by 3.
Divide 3 by 0.
Why do you do that?
Just obvious.
He's on the bottom.
I'm looking at the x-intercept. I'm not doing the vertical asymptotes, I'm doing the x-intercept. X-intercept are the zeros of the numerator, so I do that first. I have an x-intercept at 0. That's what I'm doing. Then I go to my vertical asymptote. Where are my vertical asymptotes on this one? Plus minus 2. Set the denominator equal to 0. If you set that equal to 0, you get 0. We just did that. Oh, you're doing the horizontal. Okay. Now, where's my horizontal asymptote? Now it's at the horizontal asymptote's at 3 because your degrees are the same. So as you start to go through and look at what this is going to start as, notice how we've broken this into 6 different regions.
Yay.
Okay? We've broken it into 6 different regions, but we know one value for certain. I have an intercept at 0. Okay? Which means I'm going to need to check it in a bunch of different spots. I'm going to have to check it in 2 spots within each of those domains. So I'm going to check it at -3, -4, -1, 1, 3, and 4. Because I have to know what's happening within each of those domains. Okay? That'll get me placed into one of those other spots somewhere to see what the curves are doing. So start with the easy stuff. Start with 1. What's 1 squared? What's 3 times 1? 3. What's 1 squared? What's 1 minus 4? What's 3 divided by -3? So at 1, it's -1. At -1, it's also -1. So here it's doing this. Because you only have the one intercept, it's got to go up, touch, and come back down. Otherwise, you'd have 2 intercepts. At that point, yeah, within that domain. Okay, but let's get to the other stuff. Let's use 3. What's 3 squared?
9.
What's 9 times 3? So you get 27. What's 9 minus 4?
5.
So that's 5 and 2/5. And it's also the same thing at -3. Four, 5, 2/5 here. Use 4. What's 4 squared? What's 16 times 3? 48. And then 4 squared is 16. 16 minus 4 is 12. So you wind up here 4, 4, and -4 and 4, which means it's doing this. Real fast before we get out of here, because I know we're running out of time. What would your domain, you know what, we'll finish domain range on this one tomorrow. What I have for you guys tonight is I just want you to, I don't have any graphs yet, because we still have to do some more graphs before we go. What I want you to do tonight are going to be the problems where all you have to do is label all of your asymptotes, x-intercepts, horizontal asymptotes, things like that. So this is 9.3, it's page something. Where's your one? Sorry, I forgot to write it down. 550. I want you to do 11 through 19. All you're doing there is labeling all the important stuff. No graphing. Label the important stuff. One of the things I would ask that you do, try to figure out your domains and ranges, but in order to do your domain and range, you will need to put the function into the calculator, because a lot of these are going to be really weird to graph. By looking at it in the calculator, it'll help you learn to play with the window a little bit more to see what it's doing so you can list out the domain and range. So try and do that also, okay? And we'll continue graphing tomorrow. It's exciting.